Hi guys, welcome to your first flipped lesson, lesson 9.1, solving quadratic equations using graphs and tables. We just got done with topic 8, learning about quadratics. Now topic 9 is still quadratics, still looking at parabolas, but now we're going to be solving them, particularly solving for x. So just a quick overview of our vocab. You can pause anytime if you need, but our main goal in topic 9 is solving for x-intercepts. We haven't really talked about that much this year. Solving for where we cross the x-axis. We have a lot of fancy words for x-intercepts. We also call them solutions. We also call them zeros. In Algebra 2, you will hear them being called roots. These are all just the same meaning. They all have the same meaning, but really what we are referring to, solutions and zeros, we are looking for x-intercepts. Let's take a look as to how this is going to work in example 1. It says, why are the x-intercepts of the graph of a quadratic function important to the solution of a related equation? So we have the function x squared minus 16 equals 0. I want you to just consider for a second, what numbers could we plug in for x that would make this true? So in other words, what can I put right here so that when I square that number, subtract 16, I equal 0? If you want to pause for a second, go ahead and think about that. There's actually 2 answers. All right, those 2 answers, if you got them, awesome. If not, that's okay too. All this topic is learning how to get these 2 numbers, 4 and negative 4. If I plug those numbers in for x and I square that, we're going to get positive 16 either way. And then minus 16, we result in 0. So what we call these 2 values, 4 and negative 4, those are x-intercepts. And more particularly, the words that we might use more are zeros or solutions. When we ask for the solution to this function, we are looking for the x-intercepts. Let's go ahead and plot those on our graph. We're going to use those intercepts to graph our parabolas. So x-intercepts, where we cross the x-axis, 4 and negative 4. Now, let's just make note of that as well. The x-intercepts are not just when we cross the x-axis, but when the y value equals 0. On the other hand, the y-intercept is when x equals 0. If I write these x-intercepts out as coordinate points, here's what we mean. So that x-intercept is technically 4, 0, and this one is negative 4, 0. Notice how the y value is always 0. So making note of that will also help us going forward. All right, now I just want us to draw a little sketch of this parabola. We're going to get more into details later on, but we know this is an upwards U-shape because our a value is positive. We actually have a y-intercept of negative 16, but that's going to go way off our graph. So for now, that's what we're using. We're going to use our x-intercepts. And how we would state our solutions, we would say that there are 2 real solutions. When you get to Algebra 2, you're going to learn about imaginary numbers. That's not our focus right now, but we have 2 real solutions that we can see, 2 x-intercepts. All right, for these next 4 functions, I actually want you to pause the video, go over to Desmos, and just type these in. You can actually disregard the equals 0 for now. You don't have to put those into Desmos, but I do just want you to type in the functions to Desmos and sketch graphs of each of those. Go ahead and pause the video and do that right now, and then we'll come back together and talk about it. All right, let's go ahead and come back for the first function. Now, when we graphed this first one, we should have got something like this. This is totally not perfect, but I just kind of wanted you to see a little bit about what that function looks like. Now, again, not perfect right now. It's okay if you didn't plot 3 points, but what I really wanted you to see is our solutions. So find the solutions means we want to find the x-intercepts. Now, right now, I actually don't even want us to state what they are. I just want to know how many. So how many times did we cross the x-axis? Only 1 time. So we would say this function has 1 real solution. 1 real, 0. 1 x-intercept. For the next function, we had something like this. Again, totally not perfect, but I wanted you to see where our solutions were. So for this one, how many times do we cross the x-axis? Not at all. So this one has no solutions. The solutions can only be found as x-intercepts, and sometimes there is no x-intercepts. That's okay. We would just say no solutions. All right, next one down here, when we draw a sketch of this next graph, we got something kind of like this. It was a pretty wide U shape and looked something like that. Totally not perfect, but if we are asked the question, what are the solutions or how many solutions, we would say that there are 2 different places that we cross the x-axis. So there are 2 real solutions. That's how many solutions we have. Now, bonus, this one does say what are the solutions. It looks like we cross the x-axis at +6 and -6. So those are the actual solutions. Try to figure out where we got those from in our function as well. All right, last one over here. When we sketch this last graph, it looked something like this. And for that one, we only cross the x-axis 1 time. So we would state there is 1 real solution. All right, in our next examples, we'll figure out how we can get those solutions exact.